Pay attention, this man is really too ruthless. This man's name is Xiao Shuai. At the beginning of the scene, Xiao Shuai has to do homework to explore the algorithm to warp the maze because of the programming, but he is struggling with this because of the language barrier. He suddenly thought that, as the saying goes, water can carry a boat and cook porridge. Maybe water can also walk through a maze.
水哦。
We are curious about the head loss during the process. First, we need to determine the velocity at point 2 by applying Bernoulli's equation. As we set point 1 as the datum point, Z1 will be 0 and Z2 will be minus 31.6 millimeters. We also assume the water at point 1 is static, that is, V1 equals 0 and P1 equals 0, since P1 is gauge pressure. We note that P2 is the pressure below the water, simply equal to gamma times Z2. Plugging this into the equation, and after some calculation, we can acquire V2, which is 1.11 meter per second. Next, we are going to find hydraulic diameter, denoted as dH, since our tube is a four-edged polygon. The hydraulic diameter is defined as 4 times the cross-sectional flow area divided by the wetted perimeter, which is 0.01 meter. Then we assume the temperature of water is 15.6 degrees Celsius. By looking up the table in our textbook, we can acquire the kinematic viscosity of water. After that, we can calculate the Reynolds number. We find out that it is much larger than 2000, so the flow is turbulent. Then, we can calculate relative roughness, which is Epsilon over D. By Moody chart, we can get the friction factor F equals 0.032. We then have the major loss, which is 0.129 meter. This is the analysis of the maze. It contains 20 90-degree bend, 10 branch flow, and 2 lined flow. So the total loss coefficient is 32.4. We then have the minor loss, which is 2.035 meter. Finally, the total loss is the summation of the major and minor loss, which equals 2.164 meter. We now want to discuss the time needed to travel from point 2 to point 1. We consider the whole mass a controlled volume. By continuity equation, the mass flow rate into the system equals to the mass flow rate out of the system. The time required from 2 to 3 is the length divided by velocity, which is 0.58 seconds. But our experiment result shows that the water need approximately 4 seconds. This is because we assume the flow is fully developed, but in reality, it may be a developing flow instead.
The purpose of this story is to tell everyone that when we feel lost on the journey of life, we should not be afraid because, just like water, we have the power to find our way out of the maze. In these videos, we see water utilizing various techniques and resources to confront challenges and ultimately succeed in finding an exit. Throughout this process, water showcases qualities of resilience and unwavering spirit. The little fish knows to hide here because it has attended Professor Yubin Chen's thermal fluid course.
Learning Professor Chen Yubin's thermal and fluid science is an honor and a source of pride. as well as the driving force behind my pursuit of greater heights.